Great. Hey, everybody. I'm Alex. A couple of quick things. I have been slowly, actually quite rapidly, descending into illness today. So the likelihood that this starts standing, and then I sit at some point, and then I just lay down on the floor for a while, that's a reasonable expectation of how this is going to go. So I may just kind of have to call it at some point. And the way I knew I was really sick is I was offered coffee, and I realized I just absolutely didn't want coffee, and so I must be grievously ill. So I'm Alex. I'm going to talk about, I think actually data science is maybe not quite the right word, so I'm going to call this a talk on data technology. It's more about how we at the Urban Institute, and so I'm a data scientist at the Urban Institute, which is a think tank in DC that I'll talk a little more about. And I also run and teach in a program at the University of Chicago in data science-y things. I'll talk about both of those. But data science is a lot about methods. Actually, a lot of what's happened recently that's so interesting is tools and technologies that are far more available to social scientists than was true 10 years ago. It's certainly been far more democratized. So I want to talk about that more broadly, the data technology side of this, and how it enables new data science methods easily, right? There's a lot that a social scientist can do today that would have been deeply unreasonable to expect them to do 10 years ago. It's not that everything's new and magical and different. We have a lot of these methods before. It's that the technology and the tools will enable you to do them far, far, far more easily. And so they're worth knowing about. The requisite me slides, this is me, Twitter and whatever, I teach classes. The two things I'm really proud of that I should mention, Georgetown is starting a joint degree in this space. It's a master's in data science for public policy. I built that program in 2016, and it's starting this year in the near future, in the fall. And it's actually based on the program I run now, which is the Computational Analysis and Public Policy degree at Chicago. And basically, everything I'm about to say is, I'm a broken record. It's the same thing over and over again. All these new methods are useful. There are new tools. We can make them available to social scientists in a couple of years. We should be doing that with serious pipelines of people and giving them depth and technical skills that are going to be useful for the next sort of generation of policymaking, of social science research, so on and so forth. Cool. So you'll notice largely absent from this talk is going to be machine learning. Totally important, falls easily into the rest of this, but I'm not going to talk about it because Raed Ghani was here yesterday, and I'm just not that stupid as to try to talk about something that Raed Ghani just talked about. So I'm gonna glaze. You won't hear about this again, but hopefully I'll talk about some stuff that you didn't hear about so far. And DataViz is the one that I'm going to start with. First, because if you want people to pay attention to your talk, you should show them pretty pictures a lot. And so the Urban Institute, we have 11 policy centers, 500 staff, over 300 researchers, all looking at disadvantaged populations and the public policies that affect them. And what's interesting about being at a big organization, big for social science with 500 people, is that we've been building centralized and available infrastructure on a lot of different levels for policy researchers. And one of them is we have a full-time dedicated DataViz team, and that's 3 people at the moment. And that's all they do. And this has led us in some interesting directions. This is the prison population forecaster. And if you look at this right now, this is going to look pretty much like every web tool you've ever seen. It has some buttons at the top. There's a line graph. These are showing us for 15 states how many people are currently in prison in those states and how many are projected to be in those prison in those states over time. Time is going left to right. Thousands of people in prison on the right. For those 15 states, criminal justice data is very hard to get and standardize. I think it might be the single worst area of public policy in terms of data, especially across states. And so getting 15 states is a non-trivial, like the hardest part of this was getting 15 states worth of data. And then you have a tool and you can examine some other scenarios. So currently in magenta that's our highlight color, that magenta color. That's the default, that's what happens without any changes. But what happens if we take drug offenses, we reduce the length of stay by 50% across these 15 states? Okay, so I changed the scenario, a couple buttons, we have a different projection, actually not that big of a difference, and one of the key takeaways from this analysis was we hear a lot about reducing jail time and jail sentencing for drug crimes, and it turns out there's just that's important, and we should probably be doing it, but it's not a huge part of the equation. So what's interesting, so far really what I've shown you is nothing actually that different from your classic web tool. What Urban has started to do in a way that's fundamentally different is make their data visualization a first-order citizen, an absolutely like first-class citizen in its analysis. And here's how you can tell. I'm going to scroll, and the text is going to move, and the graph is going to remain. This actually stays there the whole time, and if you look at the percentage of screen space occupied by data and graphs at the Urban Institute, it's probably closer to 70 or 80% in a lot of what we do. Now, we still do big PDF reports, but they get the views that big PDF reports get, and if you're familiar with producing social science or policy research, that could be sub 10, maybe 20, 30, 40 if you go speak at a conference. 100 if someone retweets it who has a following. But I mean, it's grim, right? We see orders of magnitude increases in viewership when we put the time in to build what we call a feature. So mixed data visualization and policy analysis. And this does some cool things. We can actually select specific scenarios that are being talked about in the text. And when we click on them, there's this little, I don't know if you can see this, but there's this little like magenta line graph thing and blue underline, and when you click on that, the graph changes to the scenario being discussed in that passage of text. So this one about Michigan specifically. Okay, cool. This, by the way, is all done in D3, and if people are interested in how this is done, I'm happy to talk about it. I teach this stack of tools, which is very similar to what the New York Times uses, in my data viz class. And we see lots of variations of this that let us show people a lot without throwing too much at them. So here's another story, and what we have here, this is about, in DC, the distance people have to travel to go to school. This is something that's associated with lower attendance, it's associated with kids being more tired, which basically has bad outcomes across the board. And this is particularly important if anyone has studied charter schools. When you start implementing charter systems, the distance that kids have to commute to school is almost guaranteed to go up. Very frequently, it's going to go up. And what we did here, I think this is dumb, but I sort of love it. See the blue dot next to the name? That blue dot is that person, and you're going to follow it through the visualization, and it's going to become part of the graph, and you can watch that specific person on their school commute, as long as all the other commutes from that, from 6th grade students in Ward 7, for which they had data. And so there's an element of this that becomes storytelling, right? Not only are we literally going to use a lot more data and do it in line with our text, we're going to highlight a person, create their data point next to them, and then kind of drag it onto a graph, right? It's very much about the idea of like, let's tell an actual human story, and let's do it while showing you the data. Right, sort of bridging this empiricism, the Urban Institute, very, very quantitative, very empirical, but we actually want to tell stories that people like listen to. So this is a good example of that. A couple other things we do, a little more classical data viz. This is our NAPE tool. And we spend a lot of time just thinking about how to make data visualization. The hardest part of data viz is actually just making something that is fully like informative and not just throwing a massive amount of information at people. This is another thing that D3 does well, which is for each of these, this is an adjusted versus unadjusted score for NAPE, which is the National Assessment of Educational Progress. That is a national test of standardized school performance for students. Math and science and reading, depending on what grade you take it in. And what this is in yellow is the unadjusted score by state, with higher scores being on the right. And in blue is the adjusted score. This is adjusted to what you would expect that state to do, given socioeconomic status, and I think a few other factors. So it's like a weighted score. You would expect, just based on the population of students, that it would be harder to educate people in Mississippi than Connecticut before the schools did anything. Right? That's sort of hopefully fairly straightforward. And one thing you can imagine doing is, this is just these two adjusted scores, is talking about rank and maybe talking over time. And so what we did is actually just detail on demand. When you scroll over a specific state, this is Mississippi, you see its rank ordering of all states over time. This is actually Mississippi rising up through the ranks pretty dramatically over the last, I guess, 10 years. Actually, only like 5 years or so. And this is another thing made possible by D3. So if you come to a program like the Georgetown program or the program I run, and I'm saying, I'm going to teach data visualization to policy people, let's teach them web development, right? There's a full day in my data viz for policy analysis class. That's the basics of web development, because this is a huge deal. First of all, you can't build these things without it. The technology is fairly complicated. But two, we have a real sense that policy research is not disseminated widely. And the art of making it accessible and making more people engaged with it while simultaneously not watering it down is really meaningfully difficult. But we have a lot of new tools to do it, and I would argue that DataViz is one to really seriously consider. I should give credit to this team. This team right now is led by Ben Chartoff, who's a really excellent DataViz developer. And all of these have, I realize I can't name everybody because these are from different times and credits will appear differently at the bottom, but they are all credited. Also, all of this stuff is public on GitHub, all of our databases. We also do maps. Maps are a thing we do just because people like maps. This is a fairly straightforward one. I'll show you one that's slightly more interesting. This is a fairly simple graph. It's on the left, it's a lot of education stuff. On the left, it's funding per full-time student, so just a simple state funding calculator, like how much money are you spending per student. And then on the right, it's funding relative to the wealth of the students. So it's a ratio of, so essentially higher on that is more funding. So for instance, it's harder for New Jersey to be high up on that because it's relative to the wealth of the state. New Jersey is a very rich state. And so what's interesting about this actually is that the idea of this was to show the state-by-state variation. So this is a state-level graph, right? The lines on the left, each one of those is a state, and obviously the states that are in the right, each one of those states. But you'll notice the state is actually, the map itself is actually very small. And if you look at the map, there's a reason why the map is very small. There's actually no geographic trend here. Right, when you look at this, the blue, which is the funding per student, it's not like the Southeast is particularly terrible and the Midwest, Pacific Northwest is amazing. The geographic aspect that you might expect to be there simply isn't there. And so the map not being particularly important means that we're really only using it as a tool to help people find their state. And by that I mean, rather than scrolling through these lines and trying to find a state, you can just scroll over the state and find your state. And what we know about maps is that everyone can find the state they're from literally immediately. So if you want to think about this map, it's not really about the geospatial element. This map is there because it's better than a table for looking up your state. And that's actually a fairly routine thing. And this is fundamentally different than, like, there's definitely a trend out there in the moment in DataVis to dramatically overuse maps. Even when there's no geographic trend. I think there's a lot of ways to attract people's attention and use them meaningfully without necessarily claiming everything is a geospatial analysis.
So I guess the ultimate fun would be using maps for navigation.
Yeah, thanks. Can I? That brings up a good point. I'm happy to talk about whatever, to take questions as we go. I have no agenda whatsoever, so whatever is useful to you guys, I'd be happy to talk about. I'm going to cover a couple other I'm going to cover cloud computing and big data as the other two things I thought were cool. But if we want to totally tangent onto whatever, that's fine too. Yeah, please.
I'm just curious, so far you showed us a couple of different graphs. Do you have any principles or guides for good data visualization?
Sure do. Great question. Credit to Amy Cecil, originally of the Sunlight Foundation, for doing this first. So the Sunlight Foundation was a think tank, is a think tank that does civic technology and open data as well as government transparency. And Amy Cecil was a designer there, and she built the first one I've ever seen, a style guide for data visualization that includes sort of guidelines for best practices. And so we have this. This is public. The Sunlight Foundation one is also public, though it's on Amy Cecil's GitHub is the easiest way to find it. And John Schwabish, who is also of the Urban Institute, he has a blog and a website, John Schwabish, and a book, thank you, called Better Presentations. And John Schwabish's blog has a list of data visualization style guides. And so these both have style guides, as in how to consistently brand for your organization, but they also have a lot of good tips. That didn't work. But anyway, Googling failed me. But anyway, there are a bunch of these out there. Sunlight and Urban are quite good. And they do everything from set up exactly what fonts we use in what situations. If you're wondering how intense they are, they set the number of pixels between our subtitles and our axes. I mean, that's the level of granularity that these things go to. They set our color maps, which can be a meaningfully difficult things to do, especially color maps that are colorblind safe. So there are a bunch of good efforts out there. If you're building a style guide, I strongly recommend you steal from the many people, good designers, who have put a lot of time in and made them public on purpose. That's what they're trying to do. One more quick note on maps. This is actually the same kind of thing. The geospatial trend isn't really the point here. We just know people want to look for their state. We also think they might want to compare different states, and putting 50 lines on this one graph might be too many. So instead, we have on the left how progressivity of school funding has changed over time. And then on the right, you would call this a small multiples or a lattice of 50 states. And rather than just laying them out in the grid, we've laid them out in the actual shape of the United States. And you're seeing more of these, sometimes called tile grid maps. Hex bin maps are another example. There's a bunch of them. And so from here, I could point and click and now compare Ohio and New York on the national map. And these are all kind of experiments, but what we're trying to do is show a lot of complicated data to a diverse audience and make it meaningful and approachable. And it turns out that most graphs don't do that. If you seriously stray away from the line charts, the bar charts, the scatter plots, the bubble charts, you're in trouble real quick. People cannot interpret Sankey diagrams. They cannot interpret chord diagrams or network graphs. You know, the vast majority of graphs that you think, man, that's really cool, you are going to lose 95% of your audience, hands down. And I think the important thing to remember is that once you are done making a graph, you have no influence on the takeaway that the audience has anymore, right? Once you hand it to them, you really don't know what they're going to take away from it. And the more complicated graph type, the higher variance of what's going to come out of the interpretation. So this is a thing we do a lot. Last plug, urban.org/features has all the interactive graphs that we do. Yes, please.
When you say you don't know what they're going to do with it, do you have any, for lack of a better word, trackers on to show what people do? Have you ever learned from your users they're attempting to do a non-intuitive behavior or something where you've gone, oh darn, we forgot that, let's give them that?
No.
Something like that.
No, that'd be awesome though. There are studies about accuracy. So there's a great data visualization lab at University of Washington. And what they will do is they'll show charts and ask people just simple things like, what number does this represent? And you can see complicated charts. For instance, the difference between a tree map and a bar chart is huge, right? You lose a dramatic amount of accuracy when people are comparing different rectangle shapes, rectangle sizes versus bar heights. And so we know simple stuff like that, and we try to extrapolate. But no, we don't, and it's really expensive to find out, right? Even just deciding who your audience is hard for us. So that was a bunch of D3 stuff. I might also mention, I showed you that we have a theme. If anyone here is an R user or likes ggplot, we actually have our Urban Institute theme fully implemented in code. I shouldn't say fully, mostly. But this is our code for a ggplot theme, and it looks like this. It's a good example, something with a bunch of colors. There we go. So this chart comes directly out of ggplot in R. So there's no hand-done anything. That's automatically urban colors. That's automatically Lato, which is our font. The layout is pre-organized to some extent, right? The location of the subtitles, the sourcing, these types of things. It's not perfect, but pretty good. If anyone is on Twitter, FT, which I think is the Fiscal Times, maybe, they just published their first graph that was exclusively ggplot, as in it like never went to Illustrator or a design software of any kind. So anyway, there's a move towards this, towards fully automated graphs, which is kind of nice because they're fully reproducible as well, right? It's a lot easier to make a mistake if you're dragging things around in Illustrator every time. Yeah, please.
Is this a package that I can install?
Yeah, sorry, technical things. So ggplot is the R package for visualization, sort of the status, the default best one. A theme is a set of our ggplot2 code that sets a bunch of styling guidelines in advance, and you can just apply it to each chart. So once you've done it once, you can just turn on the theme and apply it, and your charts just come out like this. And
Urban Institute stuff is all built in already if I update?
you would have to grab our GitHub page and install and run it, but it would be fairly easy. Okay, data viz. So that's the thing we do. And I think, again, the technology is right. So the best data viz software in the world is ggplot in R and D3 in JavaScript. They're both free. So it requires knowledge, but the barrier to doing these things has gone down dramatically. And I would also argue that data viz literacy in the people reading our research has gone up at least somewhat. So let's talk about cloud stuff. A little bit of a departure, but hopefully interesting. You've all probably heard of the TPC model at some point. If you're ever paid attention to a presidential election in the United States, at some point the candidates release tax plan proposals. This happens pretty much every time. It's happened at least for the last 4 cycles. And when they do that, what you want to do is take the proposals that they put forward and model quantitatively what would actually happen. Guessing at how the tax code works in terms of revenue for the federal government and the distribution of income afterwards is like completely impossible. It's insanely hard, right? There's too many interwoven pieces, too many interaction effects. And so the Tax Policy Center at the Urban Institute has a model. It's like 100,000 lines of Fortran that basically can mimic the entire federal tax system. It's the only non-governmental model that does this. There are governmental models, that Congressional Budget Office, that the Joint Committee on Taxation, but they're not actually going to do this for a presidential nominee. So first of all, they don't, different coverage of use cases. Also nice to have one that's not the government. And so it's built on something called the IRS Standards of Income, basically released IRS data, merged with CPS data, and then each row of data is one of 145,000 representative weighted sample of the United States, and you can just imagine that each one of those rows is having like TurboTax done to it, right? It's being optimized for how it would file under the best case scenario for all of its conditions. And then after that, we produce, based on all of those revenue and distribution estimates. And so this is what that looks like. This is the Bernie Sanders tax plan from 2016. And what you're looking at, the left half is the more important half. That is the distribution of income by quintile. And so basically, under the Bernie Sanders tax plan, this is after-tax income. Basically, everybody's going to lose money, but rich people in the higher quintiles are going to lose more money. And if you're Bernie Sanders, this is all fine and good. Basically, the whole proposal is that people with lots of money can afford to lose more, and then we will pour that money into social services, right? This is the whole thing. But we can put real numbers to that. I can tell you, if based on your quintile, actually based on your decile, how the income is likely to affect you. And we also have a calculator version of this where one person can go check based on the Hillary Clinton tax plan, how much is my income going to change if this were enacted? Okay, that's useful. This is like a meaningful thing. This is a microsimulation model. We have a couple of them. We do one for health insurance policy. We have one for the social safety net, SNAP, TANF, that kind of thing. The problem with this is that it's comparing two things, and that's it. It's saying, here's the baseline, here's current tax policy, and here's one alternative. And this takes about 15 minutes to run on a laptop. Okay, so what does cloud computing get us that this does not? Basically, what we're going to do is we're going to go through a fairly complicated process of taking this and deploying it to the cloud. And once we do that, we can run the model an arbitrarily large number of times for fairly cheap. Which lets us ask a couple cool questions that I'll get to in a second. Different than, is this policy better or worse than this other policy? Because remember, the policy generation process at present is completely subjective. It's 24-year-old congressional staffers who have like, a grand total of, 2 hours a week to learn about tax policy, throwing stuff together and hoping someone buys into it, right? I mean, it's like, just imagine the process is total anarchy and terrible. And that's how we end up with like the awful tax proposals that we get. Okay, so quick on process. This thing wasn't version controlled, so that was part one. Put a huge model into, and by huge, 100,000 lines of code. The number of tax parameters you can change is in the thousands. So you can change, everything from, how many tax brackets there are to how much should higher education tax deductions be and how do they phase in over X amount of income that you might make. So version control. We had to cloud deploy it, so this means it had to be in a Linux-compatible version of Fortran. We containerized it with Docker, and note that so far these technologies, GitHub totally open source, and Git open source free, and GitHub for nonprofits is also free. If you didn't know that, it's very useful to know. AWS is not free, but it's going to be elastic, meaning we only pay for what we use, and I'll talk more about that in a minute. Docker, free containerization software, and then parallelized with R. So we did some internal work to make each part of the model a little faster. Okay, so what can we do with this? One thing that's cool is we can increment policy changes. So let's say you're going to change 30 pieces of the tax code, and then you look at your bar graph at the end, and you're like, okay, some people made more money and some people made less money. But I just made 30 changes, right? Which one of those changes, or what combination of those changes, led to the particularly large changes in income for people? And you could probably subjectively surmise about some of this. But again, it's complicated. There's a lot of interaction effects here, right? The phase-in for the child tax credit and the earned income tax credit interact in very interesting ways, right? These are non-trivial complexities of the tax code. And so what happens if instead of running just the baseline scenario and the end scenario, we run every permutation of the changes between the first scenario and the last scenario, right? And this is a factorial. So if it's only 5 changes, it's then 5 times 4 times 3 times 2 times 1 changes, or runs of the model. And so this becomes almost immediately infeasible to do on a single computer, but fairly arbitrary to do in the cloud. Right, because we can spin up a machine that can do this 5 times simultaneously in about 10 minutes or 12 minutes. So it can do it, say, 4 times an hour. That's 20 times an hour, and that machine cost us $2.50 for that hour. And if we want to do it 40 times, we just paid $5, and it doesn't matter if we double the machines or have one machine take 2 hours. Sort of arbitrary exchange. Okay, cool. And we're working on this now, by the way. I should say this research is currently funded from the Sloan Foundation. So we're halfway through. It works. We just have to write papers and make some visualizations and talk about it. But this is, I wouldn't say in production, but in like final stages of testing right now. This one's kind of cool. We can do random draws from a parameter distribution. So instead of saying like, let's say we're modeling all of our tax reform off a really important number that we could be hilariously wrong about, like GDP growth over the next 10 years. We have 10-year models of tax policy, but they're incredibly dependent on what the GDP growth is going to be, right? And so right now, we just pick a number. I mean, I don't want to, there's some research involved, but let's not, this is how social science works sometimes. We're just picking a number and saying, hope that's right. Not only do we not have a what-if scenario, like, if this happens, how does it change the tax plan? We also don't have any intervals of confidence, right? We can't say how certain or uncertain based on huge critical underlying factors like GDP is this. And so one thing we can do, instead of saying, okay, GDP is going to be 2.4% growth rate annualized over the next 10 years, we can say mean at 2.4, let's draw across a distribution, normal distribution around that, probably based on some historical data of growth, probably since the 70s. And then see what happens with the model. And then we can give at least some metric of uncertainty in our modeling based on that. And again, I think you could reasonably argue this is in the top 5 most important models in policy, certainly in the U.S., because of the frequency of its use, and the coverage is nuts. The coverage is near complete. And then one more, which is pretty cool. This is the one that got me excited about in the first place, the idea of grid search. So as I mentioned before, the current process of proposing a tax policy is exactly, here's one proposal, come up with subjectively, probably by people who don't understand the tax code very well, and then we compare it to the baseline. When we have arbitrary large numbers of model runs, we could build matrices of parameters and test all of them, right? So we can, take 15. I think we're starting with 5 parameters and 10 options each, which is 10,000 model runs. That's an exponential problem, which is a lot, but we don't think we'll have to stop there. It'll just be a question of who wants to fund us to do research. But, you think about a researcher time. Researcher time at an organization might be like $100 an hour, right? That's a lot more than the compute costs, almost always, even if your compute's pretty serious. And so what we can do is say, we're going to try every value of the earned income tax credit with every value, every amount of, say, the child tax credit per dependent, with exactly where we should have the phase-ins for, the steps of income brackets. Let's check all of those and optimize for what is the sort of most efficient or least revenue loss we can get while helping young mothers with children, or single-parent households with children. That is a totally empirically answerable question with the entire tax code in a way that we couldn't answer before. Yeah?
I was wondering, and I'm not really sure how to phrase this question, if you could talk about the kind of decisions that need to be made in that process in terms of a cost function that is determining what's optimal.
Yeah.
Like we
Yeah.
value this much savings for this person more than or less than, this amount of savings for that person. I mean,
Yeah.
a lot more than our typical cost of a false negative versus cost of a false positive.
Yeah, so I am thankful to be on a team with several tax policy economists who have to make those choices. Certainly there are non-trivial trade-offs. I actually think it's unlikely for us to be as specific as I just was, as to say we're gonna go find single-parent households and try to help them as much as we can without losing much revenue or without sort of creating perverse incentives. I think that'll be unusual, because it's pretty, I think because that has an agenda in a way that the Urban Institute doesn't really. What I suspect you'll see us do is someone will propose a tax policy proposal. It will be terrible and have bad incentives and will have huge loopholes and all sorts of other problems, and we will grid search around it. So we will say, instead of this, have you considered this other, relatively similar, but far more efficient, far more fair, far more like linear in that, maybe it's progressively linear, or maybe there's not quite as many king points, so there's simply less complexity or less changes. That gets a similar result that person wanted. I think you're more likely to see us do that than this is what we consider great tax policy. Though maybe, that'd be interesting. It's an open question. So that's the big cloud example. So that's funded, which is cool, because it seemed crazy and we weren't totally sure we could do it when we asked for the money, which I shouldn't say into recordings so much. Yeah.
Have you, at what stage, have you brought results to decision makers? Like, how do they, I guess I'm just thinking about, how a politician might react. We did grid search.
Yeah. Yeah, so we are currently in talks on how to do the data visualization, for which we don't have great answers yet. This is a generalizable problem. The problem is, how do you explain to people things with high dimensional inputs and fairly simple outputs, actually. The output isn't that complicated. But what we're trying to show people is that there's important interactions between 5 or 10 input values that are probably continuous. What exactly can you say about those in a way that's interpretable? Because we can only really see 3 dimensions, and right. And we really only use scatter plots really anyway. Anyway, so it's not a totally solved problem. I would keep an eye out for what comes out in the next year. We have to do something in the next year, so we'll have something in the next year. And then I think best case scenario, for policymakers, it's actually easier. So if we want to actually exhaustively explain a model run, that's hard. If we want to go to policymakers, what you probably do is we do a grid search. We pull out the ones that we think are sort of optimally just better, right? Like more efficient, less absurd, less total changes, less complexity. And then we can just show them. Like, hey, have you considered this instead? So I think in a policymaker, that's probably what happens. So we're using it as an exploratory tool, and then we choose the ones we want to communicate with. And so if the cloud technology stuff has been great too. AWS is cheap and just not that hard to use. I mean, it's not trivial to use, but again, if you've centralized, this is one of the more recent advantages of sort of working with big data infrastructure, is that, or like in a big team, right? We have 500 people in a centralized group of people that included myself and others. So individual researchers don't have to do any of this, right? Like literally none of it. We've obscured entirely cloud compute and big data analysis and microservices in the cloud away from them. They're using a point-and-click interface for this, for the cloud compute side. And this, as it turns out, this wasn't how we got started with big data, so I'm switching the order here a little bit. But this sort of set of possibilities has basically inspired us to keep pushing in a direction where we democratize to our researchers big data analysis. Some cool examples that people have done recently. There is a sentiment and police shooting project that would have been totally impossible, right? It was like every tweet over a 3-year period that said cop or police in it, which is a lot. And then sentiment analysis, which is non-trivial, right? To pull sentiment out of each sentence, that can take a little bit of time. Doing this on an individual machine would have been absurdly hard. Doing this in parallelized cloud compute environments, I think we had thought it was going to take 5 hours, and it took less than 1 the first time we ran this. And here's another one. This is a project that's actually done that I can show you sort of similarly in the what people are doing with big data and social science research. This was, can you find the same trends of residential segregation in digital segregation? So novel methods of mapping Twitter data onto census data, and then seeing if the social networks and the conversations in the Twitter space map what we think to be sort of racial and socioeconomic borders in cities in the physical space, and found that they strongly do. Right? So if you're considering Twitter as something that breaks down for a lot of people walls to their immediate community, it doesn't seem like there's a lot of evidence for that. And so those are both urban projects. But there's others in the big data and causal inference space. And the connection I should make from the cloud system here is that I'd be happy to talk about this if I don't pass out. With the same cloud systems, we now have basically single-click elastic clusters for researchers. So if a researcher gets a project and they have 5 terabytes of data or 10 terabytes of data, we can very quickly give them a system where anytime they want to do work on that, they click a button. It spins up a cluster of computers in Amazon Web Services. About 10 minutes later, that cluster has been installed with Spark, which is a distributed computing system, and R, so they can type R code and they will get Spark to run across their entire cluster, or Python on top of PySpark, sitting on top of a cluster. And so in a cluster of 5 computers, you might get a couple terabytes of distributed memory and 150, 200 processors. And so you can see speed gains of 200, 300, 400 times, which lets you work. And also just the fact that you can work with these massive data sets that you couldn't before. If you're familiar with some of the new sources of big data for policy research, this is kind of cool, right? It means that Airbnb data is useful. It means that Twitter data is useful. Finance data, like from the credit card companies, for instance, all of this stuff is suddenly on the table in a way it wouldn't have been unless we had a supercomputer. And now we have kind of an arbitrarily large compute capacity that we can give to any researcher. It doesn't matter if they're a particularly technical person. So that's sort of what led to these types of projects, and there's a bunch more in the works. Two other things I'll mention quickly. Yeah, I'm gonna skip some stuff. So if on the big data side, if there's a big data lets us use fundamentally new data sources, there's also a couple of papers I want to mention that's not urban related, but I just really like the idea of this. So these three researchers have started sort of linking big data and causal inference. And the way they did it is they took down 3.7 million social media posts from the Chinese social media company. I can't remember what it's called, but it's the Chinese Twitter, to evaluate government censorship. And they looked across all of these and came up with a couple of hypotheses, the first of which is that China's government was censoring based on criticism of government officials. And the second was that they were censoring based on organization, basically a social protest organization. And so those research, the coming up with those theories, they did in an entirely descriptive way, right? If you just grab 3.7 million blog posts or social media posts, right, you have no earthly idea who that population is. You can't link it to all sorts of other data. It's very hard to link that. Very little of it's going to be tagged geographically. So you have no earthly idea who your population is other than big picture statistics. This is true of Twitter. It's a really non-trivial problem to link it to other things. And so what you can't do is say, based on a reduced number of criticisms of the public, or of public officials over time, when we think censored, they used sort of, they used other events that gave them a proxy for when they thought government officials would be more likely to engage in censorship, though I'm blanking on what those were. And they did find reductions in criticism of public officials, but what they couldn't make a causal claim there. Right? You don't know who this population is, and you sort of don't know why. But using that data to come up with a theory, they could then test with an RCT. And so after coming up with these original ideas from all this big data, they actually wrote a whole ton of their own posts, created an RCT, and found that, in fact, the ones that were highly critical of Chinese officials were not censored at all, or were censored very, very lightly. The ones that they had come up with a theory originally and then saw a tremendous amount of censorship was around organizing for social, basically calls to action. And I would really expect us to see a bunch more of this, right? Because we don't have this. We don't have a really good, consistent causal inference framework for just sort of all this new data. But this seemed to be a really interesting sort of like hypothesis generation with all the observation data we have, and then build randomized control trials when you can't do anything else. Similarly, the one machine learning thing I'll mention for variable generation, it's the same sort of thing. New data sources can be very useful, probably not causal inference applicable on their own. But I thought this was interesting. And I'll just pull up the paper. What drives media slant? So essentially, rather than, like, if machine learning itself has no clear causal implications, right? There are such things as like causal decision trees, but no one's really biting. And maybe machine learning interpretability and explanations are getting a lot better, but we're still not anywhere near making causal claims with them. So I thought this is sort of interesting. Again, how is it related? Well, we can build outcome variables with machine learning from data we couldn't otherwise use. And this comes up all the time, but this is a good example of taking newspapers, using natural language processing. They used phrase detection in this. There's no earthly reason you couldn't update this to be a neural network-based approach, right? It's just, it's just classic. It's just a regression problem with text. So the fact that it was phrase detection is a little naive, but it's plenty of good ways to do this. And that gives you, and they match the text in the newspapers with the congressional record, which has a fairly definitive metric of partisanship, right? Whether it's their partisanship or their vote scores, stuff like that, or their campaign finance scores. And so all of a sudden, from this, they have an outcome variable of slant for the newspapers, and then they looked at traditional causal methods to look at why that's the case, and found interesting results that, basically if you're a newspaper and your population is more ideologically driven, you will become more biased in word use, which I think is interesting. And so again, while we're not talking about a direct use of machine learning for causal inference or the big data necessarily, this is another similar framework. And I'll mention the last one just because it's a cool paper. There's good work on using lasso for IV selection. And this is just way too technical, and I'm pretty tired. So it's just going to stop. But this is a cool paper. If you Google lasso for instrumental variables, you will find interesting things. And this is, again, sort of like how do we use machine learning and all this additional data to help us build meaningful causal inference frameworks. And then, yeah.
It can be used to select invalid instruments?
Yeah, well, which is the same as, it's to tell you which ones you don't want.
Oh,
right, which is sort of not exactly the same, but yeah, that's sort of useful. Yeah, it's really clever. Though there's also papers that say it doesn't work as well. So but it's an area of ongoing research. So just a little bit on that was a couple sort of different topics, but my understanding is that this is fairly early in this, and I talked a lot about the Urban Institute, but this is not unique to us. If you go talk to Paul Decker, who runs Mathematica, he will tell you this is all they're thinking about, right? It's a huge part of sort of modernization of policy research and social science research, especially on the contractor side. They'll tell you they're thinking about how do they take machine learning expertise and place it into governments. They'll tell you they're thinking about data viz. They'll tell you they're thinking about new data sources and cloud compute. Same with like MDRC, same with AIR, right? This is sort of happening across the board in a lot of these organizations. Mostly it's good news. One shout out to the thing that scares me. Guess where all this data is coming from? Overwhelmingly private sources. I don't know, watch out for that. Little concerning, right? When we become more reliant on private companies to do basic social science work, which is absolutely happening very, very quickly. The percentage of private data that Urban was using could have been as low as 5% historically, and I bet it's 2 or 3 times that now. And I'm sure it's growing. So a little bit all over the place, but just some background on my experience in data tech, and I'm happy to take a couple questions before I go take a nap. Yeah. Or applause. Applause is whichever.